go today. So problem 6.9 is about a process that consists of loading bottles. Factor A is the bottle type, that is glass and plastic, and factor B is the worker, worker 1, worker 2. This process consists of two workers loading two types of bottle types, and these are the times they take each one. So what we're trying to do is to find out which factor affects the process, since you see the times are different. What we have here is the sum of all of worker 1, the sum of worker 2, the sum of the glass bottles, data of the glass bottles, and the sum of the plastic bottles. What we have here is, since A has two levels, A and B has two levels, bottle type and worker has two letters, A and B, and it's the number of replicates you see for each one. It's a total of 16 data, and you have for each one 4, and 16 is the total of data. So in order to find out which are significant, we have to make the ANOVA analysis. First, the first factor, it's gonna be A, which is bottle type. The second, it's gonna be B, which is the worker, interaction, the error, and the total. So the sum of squares, since it's factor A, we use the sum of this one and this one between, since we are using factor A, we choose the other ones, B times N minus the total. This is the total of all the data between 16, which is the total data, the total number of data, give us 2.066. For B, we do the same. Sum of squares, now we grab this one and this one between, since we're using factor B, is A times N minus the total square between the number of data, that is 16, give us 2.58. So in order to get interaction, you need an auxiliary table. This auxiliary table, I already made it, and it consists of 4 data, which are each four possible scenarios. This is the sum of minus minus, this is the sum of minus plus, this is the sum of plus minus, and this is the sum of plus plus. So we make sum squares of this one between, since we are using A and B, we just select N minus the total square between 16. And it's very important to subtract the sum of squares of A and the sum of squares of B. The result is 0.28. then we get the total, which is the sum of squares of all the data minus total square between 16, and we get 6.43. The error gets the total minus a minus b minus ab. So here we have the sum of squares. Now we get the degrees of freedom. Since a and b are replicated twice, we use 1 because it's always minus 1. A and b, it's the multiplication of a times b. 1, the total, it's the total data minus 1, which is 16 minus 1, which is 15, and the same as the error, total minus a minus b minus ab. It's 12. The ms, we get that by dividing the sum of squares between the degrees of freedom, and we do this for all a, b, ab, and the error. Then in order to get f, we select the ms and we're gonna divide it by the error. It's important to lock the cell we're gonna be dividing, because all a, b, and ab are gonna be divided by the error. So we pull down, and as you can see, this b also is divided by the error, and the AB is always divided by the error. So this is F calculated, F table. It's the F invert distribution with 5.5. The first degrees of freedom is 1, since all of them are 1, and the second degrees of freedom are 12, since it's the error. It's 4.74, and then if the F calculated is bigger than the F table, it's significative. So as we can see, these two factors are significative. AB is not significative since it's not bigger than the F table. So we conclude from NOVA that A and B are significative and AB doesn't. So we're gonna do the residuals now. To get the residual, I already did an average table. Like the auxiliary table, because it has four scenarios: this one, this one, this one, and this one, and it's the average, not the sum, it's the average. So in total we're gonna have 16 residuals. It's gonna be this one minus the expected value. Make sure to lock the expected value, and we're gonna use that formula for these 4 spaces. So we're gonna grab them right here and right here. Okay, so the next 4, this one minus expected value, be sure to lock it up, and it's gonna be this one and down. Okay, same is gonna be for this 4, this one, observe, minus expected, locked it up, and it's gonna be this one and this one, and finally this one minus this one, so we got to lock it up. Here are our residuals. I'm gonna copy this as values these are our residuals. So in order to do the normal test, we have to transpose them. And then we're gonna paste all of the residuals. And we're gonna sort them from the smaller one to the bigger one. So, and then 16 residuals. And the probability is the place minus 0.5 between 16, which is the number of data. Press enter and we pull it down. All of them are, for example, 9 minus 0.5 between 16, the same here, the same here. So we're gonna plot in the graph and we're gonna use tendency line. As you can see here, most of the data are in the tendency line, so we can conclude that the data follows a normal distribution. So now I'm gonna do the analysis of residuals for factor A and factor B. And then we're gonna go to residuals. Residuals factor. These are the residuals for factor A. So factor A is the bottle type. And the bottle type, it's supposed to be 8 data eight residuals with bottle type, let's say 1, which is the glass, and 2, which is the plastic. And then we need to choose, these are the residuals, we need to choose the residuals that are only from the glass, which are gonna be these ones. This one, this one, this one, and this one. I chose this one because, as you can see, this data represents only the data with the glass. And then we do the same with plastic. This one, this one, and this one. So we're gonna plot them. And as you can see, we make zoom. This one is number 1, which represents glass, and this one represents plastic. As we can see, these are not the same size, which tells us there is no homogeneity. in their cereals on factor A. So we're gonna do the same for, let's make this aside. We're gonna do the same for factor B, which is worker 1, just worker, and then the same worker 1 and worker 2. And we're gonna, since this is all worker 1, this is the serials for worker 1, and these are the serials for worker 2. For worker 1, these are for worker 2, worker 1, and this is for worker 2, and this is worker 2. We plot them, and yet again we see that they are not the same size, but they look alike. This one, it's worker 2, it's definitely bigger, worker 1 is smaller, but it's not the same size, so we can say that there is also not homogeneity in the data of the serials of the factor B, which is worker. So in conclusion, we can say that in the NOVA we got the results that A and B are significant to the process. In the normality test, we proved that the data follows a normal distribution, and in the residuals, by plotting them, this was with factor A, plastic and glass. We can see they are not the same size, and also here they are not the same size. So we can conclude that neither of them are the cereals follows have homogeneity.